All right, so for question 19, they give us this following ester, CH3, C, got two hydrogens there, two hydrogens there, carbon, oxygen. All right, so esters are named in two parts. They are named in the carboxylic acid half, and right here is my ester motif, right? A carboxylic acid would be, right? So I'm looking for the part that contains that carbonyl oxygen, carbon oxygen single bond. In that part, I've got 1, 2, 3, 4 carbons. So 4 carbons, right, would be butane, but we drop the E and add OATE to indicate that I've got an ester present. So butanoate. And then my prefix is going to come from the other half of the molecule. My other half of the molecule has got 1, 2, 3 carbons in it. If it was a straight chain, it would be propyl butanoate. It is not a straight chain, right? It's an isomer of propane. So it's isopropyl butanoate. And again, it should be one word. I just didn't do a very good job of, well, I guess it shows up as two separate words, and the correct answer there. All right. The correct answer there they give you is B for question 19. Question 21. All right. Question 21, we have an aldehyde. And we've got some functional groups, it looks like. Some branches off of that aldehyde. All right, aldehydes need to be on the first or the last carbon. They cannot be in the middle. Let's see what's our last, CH3. So longest continuous chain, 1, 2, 3, 4, 5 carbons. So 5 carbons would be pentane. We drop the E and we add Al, indicating we've got an aldehyde present there. We could number it. We don't really have to, but it looks like they number it here. So, or no, they don't number it here. So we're good. So, okay, I've got pentanal. Again, we don't have to number it because an aldehyde's always going to start or end the chain. So pentanal, that takes care of the main chain. That we've got an aldehyde, and then the two things you want to add to that, I've got a methyl group on the second and the fourth carbon. So we would say 2, 4 dimethyl pentanal. So it looks like choice C there for question 21. Question 22, and then yeah, Sarah, we've got question 25 is already on the list. I think question 2 looks eerily similar to a homework question that we did. All right, question 22, that is an ether, and it is, I think, the exact same homework question. One, two, three, 4, and 5. I'll draw out the full structure if the condensed structure is kind of giving you a hard time. All right, so ethers are named in both halves, just like esters, where we're going to name the largest half is our base name. So the largest half here, largest half, I've got 1, 2, 3, 4, 5 carbons there. So 5 carbons is pentane. And my prefix comes from the shorter half, and I'm going to add the oxy to indicate the oxygen is there. So this would be ethoxypentane. All right, ethoxy from the 2 carbons there, the oxy indicating the oxygen, and then pentane meaning my longest carbon chain. All right, question 25. And it looks like we won't need a review session tomorrow night. Yeah, question 25 is an alkene. All right, this one's fully drawn, so we should be able to answer question 25, right? It's not the line angle drawing, it's the full structure. And maybe the only thing that's you're missing from this question is just one prefix that we would have to add. All right, so longest continuous carbon chain that contains a double bond because we have a double bond. So 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons is octene because I've got a carbon-carbon double bond in there. We want to say where that carbon-carbon double bond is. So we would add oct3-ene. And then if Emily's still here, right, what are we missing, Emily, from this name? All right, anytime we have a carbon-carbon double bond, we need to look for, do I have cis? Do I have trans relationship? So here we're on the opposite sides, right? We're on the opposite sides of that carbon-carbon double bond. So I would say this is trans oct3-ene. So maybe many of you are answering it correctly, just forgetting to, you're omitting that, what is the relationship across that carbon-carbon double bond? And it is a trans relationship. Yeah, question 27. You're basically repeating the same unit over and over and over again. So it's a homopolymer because it's the same building block that you're repeating for question 27.